Hiya folks, the old fossil here. Today's video is about driving a shift register with an Arduino and a 7-segment display. Folks, the way this thing works is the Arduino sends a data number to the shift register. Q1 to Q8 is MSB to LSB, and the segments on the LED, the 7-segment display, A, B, C, D, E, F, G, and a decimal point. You pick the ones you want to light up, and that's A plus C plus D plus F plus G. So if you convert that, the bit values, to an integer, the answer is 182. So basically, if you shift out an integer number of 182 into this shift register, the segments will light up and make a 5. Like I said, I had to switch parts from the CMOS shift register to a TTL shift register to get the drive current. Things to keep in mind when picking new parts. First of all, the shift register stages are fixed. They are burned into the sand of the chip. Input is into the QA or Q1 and proceeds down to QH. But that's the only thing that's really fixed. For the rest, you can use your own convention for whatever you want, but just be consistent about it. For instance, the data coming out of the Arduino can be MSB first or LSB first. The shift out instruction will do either one. The red choices here are the ones that are in the demo. Oh, by the way, LED displays, if you need a new LED display, come in 2 types, common cathode and common anode. Now what that means is, in the common cathode, the pointy ends of the diodes are all connected together, and that means you need a 1 at the back end to turn them on. Where the common anode, the back ends of the diodes are all connected together, and you have to put a 0 on the segment to turn it on. And finally, if you need a display driver to get enough brightness and you're out in the real sun, it can either be inverting or non-inverting. So make sure you get all that stuff consistent, and it'll work. I used a spreadsheet table to calculate the integers because there's no sense doing it every time through the loop because they never change. So for the segments lettered like that, the pin outs on the display itself are these, and from the TTL register Q outputs to the segment, this is the spaghetti table that interconnects them. Basically, to make all these symbols, hex, after you get past 9, the hex are A, B, C, D, E, F, and the decimal point. For these segments, you put in 1s or 0s. Oh, by the way, my display takes 0 to turn it on, so this on, off, off. And that converts to an integer 3. Same for all the rest of them. So you get this stack of numbers. The spreadsheet makes it easy to calculate and put them all in a data array so you don't have to do it every time going through the loop. This is what the thing looks like in a schematic form. It only takes 3 pins out of the Arduino. This is a 7-segment display in the shift register. And oh, by the way, these little resistors are their current limiting resistors. Basically, the LED segments are diodes, and you're driving them in the forward direction. So if you don't limit the current somehow, you can actually burn the segment out, which is why you will notice in the demo coming up on the breadboard, there is no decimal point. Oops. This is what the Arduino setup code looks like. A couple of pin definitions. These are the integer arrays that hold the numbers that will light up the correct patterns. I used this one if I just wanted to drive each bit individually. This one lights up each segment in turn, in order, and then this sequence makes the whole set of 16 numbers. A little bit of mismatch. Oh, by the way, I count time so that I can time the loop and set the pins. This is the loop code, little routine just to keep track of time, because I only change the display symbol every 2 seconds, modulo 2 seconds, modulo 2, means even seconds. Sync signal for the oscilloscope. And this, we raise the enable pin to allow the data to reach the shift register, and this is the actual shift out instruction. This is all it takes really to put the numbers in the digits array out to the shift register. 0. Okay, here we go. This is what it looks like when it works. 1, 2, 3, 4, 5, running on the 1 second loop. 6, 7, 8, 9, then the hex symbols A, B, C, D, E, F. That's it. That's the full ring of 16. That's all the segment. Well, sorry about the decimal point, folks. We all slip once in a while. Okay, that was another fun little project. I hope you can use that information to adapt it to a new set of parts. The theory is the same. Thanks for watching. See ya.